Hey guys, welcome to this today's session on the Android architecture components. It's gonna be an interesting one because the architecture components are quite interesting. They are this set of libraries released by Google that are going to make development for us developers. It's going to make it kind of easier. It's going to make it more testable. It's going to capitalize on the solid principles. We're going to have more modularization, and you will just love coding all the more. So Google announced the Android architecture components at Google I/O, and they are a set of libraries that solve some pain points that we've encountered in Android development. I'm going to be focusing on about 3 libraries today, and one of them is Room, another one is View Model, and Live Data. Now, the Room library is an object relational mapping library. It's an abstraction layer over the SQLite database that we are used to in Android. Now, if you've ever written SQLite, you will know that it's really verbose. Like, you have to write a whole lot of stuff. You have the SQLite open helpers, you have the database SQL statements, and you have to be very careful to maintain the right syntax in your SQL statements, or you're going to have errors all over your app. But Room is a breath of fresh air. Room brings Room makes it easier to write to use SQLite database in Android. So with Room, you get compile time SQL validation. So if you have errors in your SQL statements in Room will validate your SQL statements at compile time. That's before your app starts running. So using Room, you get to have 3 classes. You have a class for your database, you have a class for your entities, and you have a class for what we call the data access objects. Now, the 3 classes all come together to give you what we used to have in SQLite, the old SQLite that we used to have. So the entity, now let's take it one by one. The entity class, it's more like your database table. It's like your table schema. So it's just a regular Podro, your plain old Java object, or Kotlin. So the entity class is your plain old Java object, and you get to have your fields, and you have your setters and your getters, and the constructor like a normal Podro. But you annotate to the class with at entity, and this automatically makes this class, this Podro, a table in the database that you want to create. Now you have the DAO. The DAO is the data access object. Now this is where you put in your SQL methods, your insert method, your update, your queries, and your delete methods. So the beauty of Room is that some of these methods come built into Room, in that you can just annotate a method with @delete, and it will carry out the usual SQL delete query. You can also write your own queries using the @query annotation. Allows you to write your own queries in the DAO. So this simplifies the usual SQL code we used to write before, SQLite code we used to write before for Android. So in your DAO class, you have this. Your DAO is not a class actually; it's an interface. So you have abstract methods in your DAO, and then you annotate each of them with the function you want to carry out. So it could be a query, it could be a delete, it could be an update, and it could be an insert. So just very easy. You can also have parameters in your SQLite statements in the DAO by just adding the parameters to the methods in the DAO. Very, very easy. Now finally, you have your database class. Your database class brings together the entity, the entity and the DAO to give you a full working database. So it's an abstract class that extends Room database. That is the room library that Google created for us developers. So it extends the room database. Then you have an annotation for entity. You have at entities an annotation that gathers all the entities. Remember the entities we talked about, the POJOs that have at entity annotation on top of them. So it brings these entities together, and then you have them in an array sort of. You have your DAO. You reference your DAO in the room database, an abstract method that calls your DAO interface, and then you now create your database with a simple singleton. You should make it a singleton so that only one instance of it is called, and that is all you have. You have your full working database with room. You don't have to write a SQLite open helper. You don't have to write any kind of verbose code. And calling your database is really easy. All you need to do is create an instance of the database and call your DAO, and with the DAO you get access to all the methods you created in your DAO. You don't have to write content values, you don't have to play with cursors, you don't have to play with all the stuff we used to play with in SQLite. So yeah, makes it really interesting and something you should really dig into as a developer. Now I spoke about view model and live data. Now the architecture components work very well when you use them together, and specifically I'm referring to room, view model, and live data. So let's talk about live data first. Live data is an observable data pack. It kind of allows you to observe for changes in your data. So if I have a room database and I store some items in my database, or I'm fetching some items from a web service, and I can return a type. If I'm returning a list, like an array list of data, I can wrap it in live data. It's just wrapping it in live data is really easy. Just to put live data and then a backslash, not a backslash, but like the less than sign and then the greater than sign, and then you wrap the data in live data. And what this does is that live data is going to be watching, is going to be observing that piece of data for changes. So if you have a web service that updates regularly, every update from the web service that stores in a database triggers the live data, which is observing the data already. So it triggers this live data, and live data triggers the activities telling you that something is happening, or it takes those changes that have been made in your database and then it explodes it to the activities and fragments that are implementing live data. It's really easy, and live data is a breath of fresh air once again. Live data also observes your activities for changes. So part of the architecture components is lifecycle aware components, and these components help you watch your activities lifecycle callbacks. If you know anything about Android lifecycle callbacks, it can really get confusing at times. But live data and the lifecycle aware components, they bring something special to this. So live data observes your activities callbacks. So live data can know when your activity is created, when it's stopped, when it's paused, when it's destroyed, and all that. So it observes your activity for changes. Particularly, it observes on stop and on start. So on start, live data really starts its observers to observe your activity for change, and then trigger changes in the data or push changes to the data in your activities. On stop, it already starts its observers, and then when on start happens again, it really starts them back again. So this is possible because of the life cycle aware components. And when you hook up live data with the view model, our view model brings a really special feature. I could call it a feature. It brings a really special package to Android development. The visual issues we have with lifecycle callbacks, where when you rotate your phone and then your data either disappears or the activity is destroyed and recreated again and all that. View model is awesome because it retains its instance, whether your activity is when it survives orientation changes basically. So if you rotate your phone and you have a view model instance in your activity, when your phone or your device is rotated and destroyed and the activity is destroyed and recreated, the same view model instance is going to be called in that activity. So the view model lifecycle outlasts the lifecycle of your activity. So throughout all the callbacks of your activity, that same view model instance is still in operation. And that is why it is a good place to use your live data. So when you have your live data objects in the view model class, and this guy and they are observed in the activity, this helps that your data survives orientation changes too. So if you're doing database queries, it ensures that you don't keep requerying your database, because your data is kind of wrapped around in live data, and live data objects are inside the view model. So because of that, when your activity goes through the normal callbacks on stop, on destroy, that is on rotation. Though if you destroy your activity, like you close the app, then view model gets destroyed also. But if it's just for little things like orientation changes, the view model is going to survive that change. So if you use the architecture components, you're going to have a very robust and testable app. These three classes are also very testable. You can work with Mockito and you can test these different components, especially the view model and the room database. And also they encourage modularization a lot, and it helps for maintainability. It also reduces a whole lot of boilerplate code, and I'm sure it's something you would love. So have a nice day, and thanks for coming around. Thanks.